This is my solution to Paul McWorrter's picoW series, lesson 116. Control a DC motor from a pyqt5 client in a client-server relationship. Got a lot to talk about, and I'll try to talk fast. We'll start off looking at the server. It's essentially Paul's server, and you'll notice that the pins here match the pins over here, 14 and 15. Got some delay time constants. The PWM version of the pins and what frequency is going to be used. A little dictionary that will convert a command, which is F, R, or O for forward, reverse, or off, into which PWM pins to pick and the order to be picked. The first one is the one that will receive the 0, and the second one is the one that will receive the speed. I pulled out the off command, separate constant, some constants for speed and port. Here we set up the server, get it connecting. When it's finished connecting, do the socket, saying it's up and ready, listening on port, and it prints out the port. And then it goes into a while true loop, and it'll invoke process requests. So let's go down and make sure about the while true loop. It'll print out waiting for a request. It'll extract the request, and then it will call process request, which returns a value. You can see it up here at the end of process request, returns a message, and that message is sent back to the client. Let's take a quick look at process request. Some error checking if nothing was passed in. Process request is in the form of a command, F, R, or O, in caps, followed by a comma, and the speed, which is an integer from 0 to 100, 0 if the command is O. So we split the command at the comma, and if there weren't exactly two values, error, we pull off the first one, which is the command, the second one, which is the speed. We convert the speed to an integer if it isn't invalid, or return it in invalid request. If the command is in that dictionary, F, R, or O, we're going to extract these appropriate pins. If command is in, command to PWM, we'll make sure the speed's between the minimum and maximum, 0 and 100. If it's the off command, make sure the speed is 0. Here we extract the appropriate PWM pin values from that dictionary value, and now we do the PWM work and return command completed. Otherwise we would return invalid. Now let's check the PWM. The first one that's passed in is the one that takes the 0 value, so we send out a duty cycle of 0. If a delay time was passed in, we're going to pause slightly, and then we're going to set the speed on the second one. Okay, that's the end of the server. Now let's take a look at the client. I knew diddly squat about pyqt, so I had to go learn it, and I found some YouTube videos that helped me immensely, and I've listed the two of them here. One of them is a playlist, one of them is a single video. So most of this is not original, the layout part. What we have to import, we got sys to get that argv, the qt widgets that we need, application layout blah blah. From the core, we need for some constants, we need time and socket. We're going to have a class called main window, which is a subclass of QMain window. And before we walk through it, I'm going to go ahead and start the client. So that we can see what it's doing. We'll put it over here. We have some constants, and I found on my machine I didn't have to specify the four-dotted value. I found the name, it was picoW, and we're using port 12345, buffer size 124. So these are all constants. The UDP setup. As before, I use my constants instead of the hard-coded values. Then we get into the window setup. This set geometry is setting the size of the window and where it is. So it's at offset 700 horizontal, 300 vertical, upper left corner, and the size of the window is 500 by 500. We create the buttons. Here's the forward button, its label, and its on-click method. And we give it an object name, and there's a reason for that. I specified that down here. We get the reverse button. Similarly, we get the off button. You'll notice they're all using the on-click, so we have to identify which button in the on-click, and we'll see how. We're not going to use the names, we're going to do something else. Next we create the two sliders. We have our forward slider, horizontal, we set its range, and we set what it connects to. And it can actually connect to 4 things, and I did that for fun when I was learning, but we're only going to use values. I have the other 3 commented out. And the same goes for the reverse slider. We have a name for the sliders. We're going to use that in the connect functions. And we have labels. That's these labels over here that show the slider values. We set the initial value of the slider and the label. And then we set this message label at the bottom. So those are the fields that they haven't been put in the layout, and that happens down here in the initialized GUI. For a QMain window, you can't put a layout directly on it. You have to create a central widget and put the layout in that central widget. So the central widget is going to be a Q widget, and it's added as a central widget. Now we start. We have a vertical box for the main layout, and then a grid layout for the button area. And then we start off with the grid layout. We add the forward button in row 0, column 0. Here it is. Row 0, column 1 is the slider, and the label for the slider in column 2. Same thing for the reverse positions, and then on the 3rd row of the grid we only have the off button. And after that we add that grid, which is all of this, to the vertical box. I added some stretch so there'll be space between the vertical box for the buttons and the message at the bottom. And then here's the message at the bottom. So the stretch added this vertical space. And we have an initial message. And we finally learned how we had set the color for the button, background colors for the buttons. It's in this style sheet for the entire window. And it's a style sheet that'll handle any button. All the buttons will have the same font size, weight, padding, margin, border. And here are the forward Q push button. Here's where the name was used. Background color will be coral. For reverse, it's light green. For off, it's sky blue. And there's hover buttons, colors. When you hover over the button, the color changes. Like, for example, this is currently coral, and when I hover on it, it becomes Indian red. So here are the functions for the sliders. We're only going to use the first one, value changed. We get the slider that invoked it by calling self.sender. And now we get the name of the slider. Remember, we named it. So if it's the forward slider, we're going to set that label. So when you move this slider, this label will be set. We're not using the other three. Here are the buttons, clicks. All of them are sharing same on click, so we've got to do something similar. Do self.sender. Instead of using the name of it, we're going to use the first character of the button text. It's going to be FR or O. And we use that to set the appropriate, to extract the appropriate slider value. And 0 if it's the off button. We created the request we're going to send to the server. It's going to be that letter, F, R, or O, comma, and then the string of the value. It's either from one of the sliders or 0. And then we do a send receive invocation, and we get a response back from it, and we put that in the text down here. And the send receive is what Paul had pretty much. We send it, and then we enter a try except to get the data back. We extract the data, we decode it, and that's going to be the response. If there's some kind of an error, we create our own response and send it back. So that's the end of the main window. Here's the main code where you create that window, standard way that Paul did it. And so application, create the main window, show it, and then app exec. So let's run the thing. We can leave the server, the client, running. And get the server started. So he's up and running. Now let's watch over here. I'm going to move the forward button over to 100, and I'm going to click it. And the fan is spinning. And bring it down to about 20%. Click it again. Notice when I hover, the color changes. And it actually shut it off. Remember that 20%, that 20% was about as low as it could go. And then here's a reverse. And go to off. That's about it. Probably ran out of time. Thanks for watching.